Alright guys, so we are doing section 6.1, moving on from module 5 now. We're all done with that, we're moving on to module 6. We're doing slope-intercept form. I would probably say that this is the second most important lesson of the entire year. Number 1, being able to solve equations. Number 2, being able to graph equations. So this is going to be one way that we get to graph an equation, slope-intercept form. This is the one that you guys are most used to, so it should be more familiar. Y equals mx plus b. That's the form we're working with the whole day today. And we just have to know that the m is our slope, our rise over run, and our b is our y-intercept. Okay? So if we look over to the right, it says identify slope and y-intercept. So we're given 3 equations, and we need to identify what's the slope, what's the y-intercept. This should be fairly simple. This should just be really us pulling out these numbers. So here, when it asks for the slope, notice it's the m. It's the one that's in front of the x. It's the coefficient. So here we have 6. So our slope is 6. In the next one, we're looking for the coefficient of x, the thing that's in front of x. We get the slope is equal to 1/2. Right, and the third one, we have the coefficient of x. So the slope is equal to -3/4. And you just leave it just like that, just like you see it, just as a fraction. Okay, now when we look for the y-intercept, we're looking for what's being added or what's being subtracted at the end. What's the constant? Hey, Oh, hello, that's my cat trying to take you guys down. I'll let him say hi real quick. Hi. Sorry about that. Should be going. Alright, let's just get back to this. So y-intercept is what you're adding or subtracting each time. So if you look at number 1, you have this constant here. So your y-intercept is 5. Here you have this constant here. So your y-intercept is -3. You've got to have that negative. The negative is there. It's part of the equation. You can't just forget about it. And here's your other one, -1/2. Okay? That's all we did there. I'll give you some practice problems in a little bit, but I want to finish up all of this first. Next part we're going to look at is actually writing equations. So given information, how do we write the equation? Alright, so the first one tells us, well, the slope is -3 and the y-intercept is 6. It should be as simple as plugging those values into our equation. So we should have y is equal to, slope is our m, so -3x plus 6. It didn't say anything about that being negative, so it's just addition. That's our answer there. That's all we're doing. Next one. Y is equal to, slope is 4, so 4x. Y-intercept is -2, so -2. You could also write this as y is equal to 4x plus a -2. Means the exact same thing, either one I'd accept. Okay, this last one here, this is the trickiest one. I have several people get caught up with this slope here. So y is equal to, just write the slope just as it looks as the coefficient of x. You don't have to overcomplicate it. You don't got to separate anything. So -5/4x minus 10. Our slope is right here, our coefficient of our x, and our y-intercept is our constant. Alright, we have 2 more we're going to look at. Now we're going to look at a graph. So using this graph here, and this graph here, how do we write out an equation? So if you think about everything that we've known so far, we've needed to know the slope and the y-intercept. So using this graph, we're going to find the slope and the y-intercept. Y-intercept's easiest, so we're going to find that first. So we have our x-axis and our y-axis. So we're going to be looking on our y-axis for our y-intercept, and we find our y-intercept right here, which is at 1, 2, 3. So our y-intercept is 3. Okay? Now to find our slope, we're going to look at our rise over run. So we have 2 points here. We're going to look at our rise and our run. So our rise from this point to the other point is 1, 2, 3. And our run is 1, 2. So the slope is rise over run. 3/2. That's the only information we need to write out an equation. So when we go to write out our equation here, we get y is equal to 3 halves x, mx, slope times x, plus the y-intercept, which is 3. Okay? This next one I'm also going to do with you guys because it is a little bit trickier. So we've got to find out the y-intercept and the slope. So first thing we do, we're going to look for the y-intercept, so that's a little bit easier. We look along our y-axis, and we see that right there is our y-intercept, which is at -1. So that's equal to b, that's equal to our y-intercept value. Alright, and then when we look for slope, we have our 2 points here, so we're going to think about how far do we have to rise, and how far do we have to run for that. Okay, to get from one point to the other point, we had a rise of -1 and a run of 1, 2, 3. So our slope is rise over run. Okay, -1/3. So when we write this out, y is equal to mx plus b. Alright, and there's our equations. So that was a lot that we just went through pretty quickly, but I think they're all really connected. So I'm going to go ahead and erase these. If you still need them, just pause the video, and I'm going to give you a bunch of example problems that I want you to work out on your own that are going to look just like this. So I'm going to be giving you guys different values for these, just making sure that you feel confident doing these on your own. Remember that this is the second most important lesson that we're going to do all year. So it's very important that you understand how you can graph a function. And there are a lot of ways that you can graph a function, but this is the most common way, and it's the way that I'll use the most. So that's why it's so significant. Alright, I'm going to start writing you practice problems so you can get started. Okay, there's your practice problems for identifying slope and y-intercept. Do it just like we did the practice problems. Also here, I'm going to use those as the practice problems, and I'm going to give you 2 graphs. Make sure that you're completing your practice problems on the left-hand side. I do want you to get credit for them when I go to grade them. Alright. There's your 2 graphs. Also write out the equations for those 2 graphs. So you're doing these 3, and these 2 all on the left-hand side. I want you to give me an equation or do whatever the directions say. Alright, pause the video now and complete that. Okay, if you're back with me, I'm assuming you've already done all this, so I'm going to go ahead and erase it. Still need it. Remember, you can pause the video or go back at any time. And we're going to move on to some more complex stuff, still looking at this slope-intercept form. This is going to be what we're using all day, this slope-intercept form, so we got to get comfortable with it. Alright, so we're still going to be writing equations given slope and point on the graph. So if we're given those 2 things, a slope and a point, we are actually able to identify or write the function out as a linear equation in slope-intercept form. So here we go. Let's say our slope that we're given is 2, and the point that we're given, we're going to do an easy one for this time. We're going to do 3, 1. Perfect. We always have to remember that whenever we are given a coordinate point, the first one is the x, the second one is the y. Always, in every case, everywhere. Okay, so We got this form. Y equals mx plus b. We're given some information. The information we're given is that the slope is equal to 2. We know that the slope is represented by the variable m. So the variable m we are going to replace with a 2. Okay. But we don't know the y-intercept, so we can't plug that in yet. We can't get an equation quite yet. So what we got to do is we got to consider, well, hey, look at this. We know an x, and we know a y. Just plug those in. Cool. So x is 3, and y is 1, based on this coordinate point. So y is 1, and x is 3. Okay. Now we can easily solve this for b. We can get b by itself. First thing we're going to do is multiply. And the next thing we want to do to get b by itself is we would subtract 6 from both sides. And we would get b is equal to negative 5. Guess what we just found? We just found our y-intercept. Yay, y-intercept. So given this, now we're able to write out our equation as y is equal to m is still 2. We already knew that from the beginning. And now we have our b. And that will be our final answer. Okay, so even when we're given the slope and a point, we can still find the equation of the line. Alright, let's do one more of these, and I'm going to have you do one on your own. Just because it's very important that we understand exactly how to do this. And we'll do one with some fractions because I know how much you guys love fractions. So the point, negative 2, 4, and the slope will be negative 1/2. Perfect. Alright, so we know that the slope is always represented by the variable m, as we wrote here. And the point we know is always going to be x, comma, y. Alright. So we've got y is equal to mx plus b. We're always going to start out with our standard form, slope-intercept. And we know that our m is negative 1/2, so we're going to go ahead and plug that in. How did I know that? Well, it was given to me. I also know an x and I know a y, so I can plug those in. Where did I get them from? Well, they were given to me. So y is 4, and x is negative 2, plus b. Okay, and when I solve this out, the first thing I have to do is multiply. And multiply these two together. If I could put this over 1 to multiply my fraction straight across, I'd get 2 over 2 plus b. Okay, when I simplify that, 2 over 2 is just 1 plus b. To get b by itself, I'd have to subtract 1 on both sides, and I would get 3 is equal to b. Cool. Then right there, what I just solved for was I solved for my y-intercept. So after I get that, I can write out my full equation. I now have y is equal to, we already knew what m was, it was given to us in the very beginning, mx plus b, and there's your final answer. Alright, so I'm going to give you only one to work out on your own, because I want to get us continuing on. I'm going to give you one to do on your own. Alright, slope is going to be, I won't give you a fraction, but I am going to give you a negative 2. And the point is going to be 3, comma 5. Okay. Go ahead and write me out the equation in slope-intercept form, exactly like we just did the last two examples. Alright, let's get a little more complicated then. I'm going to erase this. If you still need it, just pause the video. Okay. Now we're going to see how would we write an equation given 2 points. Right, 2 points that lie on the graph. So the point 1 may be negative 1, 1, and 0, 2. Perfect. Okay, so we know that every time we're given coordinate points, they're always x and y. Always x and y, that's how it's always going to be. Okay, but let's distinguish between the x's. Let's call these 1s and these 2s. Okay. So there is actually a way that we can find the slope given 2 points, right? That's kind of how we learned how to find slope. There's this equation, y2 minus y1 over x2 minus x1. Okay, we just labeled everything here. We just got to plug it in now. So we get y2, so we get 2 minus 1 over 0 minus a negative 1. Okay, when we simplify this, 2 minus 1 is 1. 0 minus a negative 1, that turns into positive, so we get 1 over 1, which is just 1. Remember, what we just found here was the slope. All that work here was to find that slope. So our slope of this function that crosses through these 2 points is 1. So we get y is equal to 1x plus b. Crap, we still don't know b. Alright, well, let's do what we did last time. We've got the slope, we've got a point, let's plug it in. You can pick either point that you want to use for x and y. It does not matter, either point. I'm going to pick 0, 2 because I just love zeros. Okay, x and y, so my y is 2, and my x is 0. So I get 2 is equal to 0 plus b, so 2 is equal to b. Cool, and what I just found there was my y-intercept. So I've got my slope, got my y-intercept. Now I have enough, finally, to write my equation. Y is equal to 1x, right? That's my slope, plus 2. Final answer. Awesome. Okay, I do not want to do another example of this, so make sure you have good notes on this so you can do the next example that I give you on your own. I'm going to go ahead and erase this, so if you need it, just pause the video. Alright, the 2 points I'm going to give you, 0, 6, and negative 2, 4. Negative 2, 2. If you didn't get that change, it's okay. Either one's fine. Alright, go ahead and get me an equation. I want it in slope-intercept form. Same process we used on the last example. Alright, if you're back with me, I'm assuming you've already completed this one. And we just have a couple more things that we're going to do, and then we will be done for the day. Okay. So we're going to look at actually graphing from slope intercept form. So we're going to be looking at equations. How do we use those to help us graph? Okay, so if I give you an equation like y is equal to 2x plus 1, we're going to be able to identify, since that's in slope-intercept form, we're going to be able to identify the slope and the y-intercept, just like we've been doing this entire time, this entire video. And that'll help us to graph. So we look at this here, remember it's always mx plus b, so this is our slope, coefficient of x, and this is going to be our y-intercept. When we use this to graph, this is super key. We have to start with our y-intercept. It's the first thing we're going to graph. So we go on our y-axis, we got to start with our y-intercept, and we put a point on 1. Okay? From there, you have a slope of 2, so meaning you rise 2, run 1. Rise 2, run 1. Right? And we can connect those as straight as we can possibly make it. And we get our linear equation represented by this equation. Alright, I'm going to go ahead and erase this. Okay, and let's do some trickier ones. Right? That might have been a little bit too easy, so let's do one that's trickier. What about if we have something that looks like this? 4x plus 5y equals 20. One way we could graph that is by finding the x-intercept and the y-intercept using a method that we learned in a previous video. But the way that we're going to do it is we're going to rewrite this so that it is in slope-intercept form. So that means we want to rewrite this so y is isolated. So remember, we've done this before. We want to get y by itself. So typically, I always circle this whole term. We're not going to touch that term until it's on its own side of the equation. Okay, so I want to subtract 4x from both sides. That's the only thing I can move right now is that 4x because I'm not allowing myself to separate the 5y. Those cancel. We get 5y is equal to, you cannot combine those are not like terms, 20 minus 4x. Okay, but we want y by itself. So finally that term's all alone. We want y by itself. Since it's multiplication happening between the 5 and the y, we undo it by dividing by 5 on both sides. Y is equal to 20 minus 4x over 5. Cool. So we got y by itself. This is where it gets a little bit harder. Okay? We have to separate out these two parts of the fraction. Right now, we couldn't identify the slope or the y-intercept because everything's all bogged together because of this complex fraction. So we have to separate it. So we're going to put the 5 as the denominator under both parts of the fraction. Okay? And then simplify. So when we simplify this, we would get y is equal to 20 divided by 5 is 4 minus 4 over 5x. When we do that, we can identify both the slope and the y-intercept. Here's the slope right here. Why is that the slope? Because it's the coefficient of x. Right? And then we have our y-intercept right here because it is our constant. It is not a coefficient. Right? When we graph that, first thing we always graph is our y-intercept. We go on our y-axis to our y-intercept of 1, 2, 3, 4. We put a dot right there. And our slope is negative 4 over 5. So rise over run. So our rise is negative 4. 1, 2, 3, 4. And our run is 5. 1, 2, 3, 4, 5. And we're going to connect those with a straight line. That's our graph of our linear function represented by this equation. Okay? Okay, so I'm going to give you guys 2 to work on your own, and then that will be it for 6.1. Okay, I'm erasing this if you need it. Just pause the video. Okay. Make sure that these next 2 that I give you, you're doing on the left-hand side, and you're going to be graphing them. So you have to draw your own graph in there, or get some graph paper from the graphing paper drawer. She's going to give you guys 3 of them to work out. I think this is very important. And so I want you guys to make sure you're practicing. All right, there you go. There's your 3 equations that I want you to graph. And just make sure you're graphing them on the left-hand side. All right, and once you're done with those, you are done with 6.1.